Howdy! Welcome to Aspire Mountain Academy. I'm Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video describes how to calculate the minimum sample size needed to estimate a confidence interval for proportions. Let's get started. So, we've talked in previous mini lectures about how to construct confidence interval estimate for estimating a population proportion. But all that begs the question, how big does a sample have to be in order to provide a reliable estimate? Well, we can find out the answer to that question by taking our margin of error equation and solving for sample size. You may recall that our margin of error equation has sample size as one of the variables in that equation. So if we take this equation and we rearrange it so that we solve for sample size, then that gives us an equation that we can use to calculate the sample size that we're looking for, that we actually need in order to estimate our population proportion. So we begin by dividing both sides of our equation by our critical value z-score. And then we're going to take and flip everything over. Okay, so taking the reciprocal of both sides of our equation. So we've got two fractions, one on each side of that equal sign. So we just flip it over and everything's still equal to everything. From this point, we're going to square both sides, so we get rid of that square root sign. And then we come over here, we're actually going to multiply both sides by p hat q hat. And now we've got a handy dandy equation for our sample size. If we want, we can actually just swap sides. So we have n coming out first, and here we have a handy dandy equation for calculating sample size. So we can use this equation pretty much anytime, but sometimes we're not going to know what our probability of success is, the estimate for p hat. So when we do that, we don't know what q hat is either, because our knowledge of q hat comes from knowing what p hat is. So in those instances where we don't know what p hat and q hat are, we can just substitute 25% for p hat q hat. This actually ends up being the most conservative estimate that we can make for those values when we don't know what the actual true values are. So in that case, our sample size equation becomes 0.25 times our z-score squared divided by our margin of error squared. Either way you look at this, you're always going to round up to the next largest whole number. This is really important. Looking at that minimum sample size, you don't want to go down. You don't want to round down, because this is the minimum cutoff line. So typically you're looking at people or things that you would count as whole numbers. You're looking at discrete data, and therefore you don't want to miss that partial, member of your sample. You want to go ahead and just round up to the next largest whole number. So let's look at a little quiz to test our knowledge of what we just learned about sample size. So for each example that we're going to look at, find the minimum sample size required to estimate the population proportion or percentage. Let's walk through the first one together. So we've got a margin of error of 0.02, 90% confidence level, and p hat is 75%. Well, p hat being 75% means that q hat is going to be 25%. The 90% confidence level gives us a critical value z-score of 1.645. And if you doubt that, just go into StatCrunch in your normal calculator, put that 90% confidence level in, and you'll see your critical value z-scores come out 1.645. Our margin of error is 0.02. And so now we've got everything we need to substitute into our equation. So we do that, substitute the values we know in, punch this out on the calculator, and out comes 1,268.45, which we round up to 1269. This then is our minimum sample size required for this example. Let's look at another example where our margin of error is the same, confidence level the same, but p hat and q hat are unknown. So what would you do here? Go ahead, stop the video, see if you can remember what to do here, try this out, and then come back. We'll see how well you did. Okay, let's see how well you did. So in the case where you don't know what p hat or q hat are, you can just assume that the product of those two variables is going to be 25%. Our z-score is unchanged because our confidence level is the same, and so our margin of error also the same. So now we substitute these values into our equation, calculate it out, and we get 1691.27, which of course we round up to 1692. This then is our sample size. Notice how significantly larger our sample size is when we don't know what p hat and q hat are. So there's a big difference between knowing and not knowing. It really pays to know, but if you don't know, then yes, you're going to use that most conservative estimate. And this is why it's most conservative, because it just inflates the sample size larger than it really needs to be. Let's look at another problem here where we're looking for left-handed people in California. So what's the sample size needed to estimate the percentage of California residents who are left-handed? We want 3 percentage points in our margin of error and a confidence level of 99%. So go ahead and stop the video here, see if you can solve this on your own, and then come back and we'll see how well you did. Okay, let's see how you turned out here. So first, we're going to assume that you know nothing about the proportion of lefties. In that case, you're going to use that estimation of 0.25 when you're looking at p hat, q hat. So punch the numbers out and you get 1849. Notice the 3 percentage points for our margin of error. Our z-score, critical value, 2.58 comes from the 99% confidence level. So we're going to use that 0.25 because we didn't know what p hat, q hat were. The critical value z-score comes from our normal distribution. Put the 99% confidence level in, out comes your critical value z-score. And of course, we're using the standard normal distribution always when finding critical values. And then the 99% is our confidence level. That gives us out our critical value z-score. Make sure you convert from percent to decimal for percentage points. So notice in the problem statement it says 3 percentage points. So that's 3%. So 0.03. Don't put the 3 in, put 0.03. And then that comes out to give us our sample size of 1849. Now, let's assume that 10% of Californians are left-handed. Well, if 10% are left-handed, that means p hat is going to be 10%, which means q hat is going to be 90%. We plug those new values into our sample size equation, and out comes 666. Or 666. I don't know if you should read anything into that. I don't know. I'm not going to read anything into it, but if you want to read something into it, go for it. I mean, it's California, people with left hands, 666, maybe there's a connection, I don't know, but this is our minimum sample size. So again, notice the stark difference in our sample sizes that we need to perform our estimate just from knowing what the actual probability of success is going to be. So it really pays to have that information because then you don't have to sample quite so much. That brings us to the end of this mini lecture. I hope you found it helpful. You can find more mini lectures for this and other courses at AspireMountainAcademy.com. Thanks for watching. I'll see you in the next video.